going to work some more examples using the chain rule. And so remember, the chain rule is applied when you see a composition of functions. That is, you see one function inside of another, and then what you have to do is you have to identify the inside function and the outside function. So that's exactly what I have here. I've got a secant function with a 1 over x function on the inside. And so this requires the chain rule to take the derivative. And so I take the derivative of the outside function, secant, and I just pretend there's an x there for now. Secant blank tangent blank. And then what the chain rule says is you put the inside function back into that derivative and then multiply by the derivative of the inside function. And so what does it mean to put it inside the derivative? Well, wherever you would normally have just an x, that's where the inside function is going to go. So I took the derivative. Now I'm going to put the inside function back into this derivative that I came up with for the outside function, and you multiply by the derivative of the inside function. And so I get secant 1 over x times tangent 1 over x. And then remember, the derivative of 1 over x is one we should have memorized, which is just minus 1 over x squared. And typically, with the negative, we wouldn't leave there. I'll put the negative out in front. So I have negative secant 1 over x, tangent 1 over x, and then the x squared. You just put it in the bottom, or you can put the minus 1 over x squared in the front. That part's not so important. The main thing is to see how you handle that inside function. So you take the derivative of the outside function, and then what you do with that inside function. So here's another one. This one's got a different variable, but the variable doesn't matter. The variable's theta. I want to take the derivative of e to the sine theta. So you do have to recognize that as a composition. That is, what is the outside function and what's the inside function? Well, in this case, the outside function is the e, and it has a sine plugged into it. The e function, the exponential function, that's where you evaluate it. So that's where things are plugged inside of the exponential function. So that's my two functions that are involved. And so I start on the outside. I take the derivative of e, ignoring the sine theta. Just pretend it's theta in this case. That's my variable. Well, the derivative of e to the theta is e to the theta. I'm going to put the parentheses there because it helps me remember that's where I evaluate. But once you recognize it's not just e to the theta, it's the sine theta, then you put the inside function back in to the derivative, and you multiply by the derivative of that inside function. And so derivative sine theta is cosine theta, and I'll just put that in front. So I get cosine theta e to the sine theta. So that's how you take the derivative of that function, that composition of functions, using the chain rule. Got one more here. Now this looks like a quotient, but I want to rewrite this derivative to start with, and the variable's t, which, whatever the variable is, it is. You can change it to whatever you like if you want. Anyway, the derivative, I'm going to say this is, I'm going to write it like that, use a negative exponent. That usually is easier to do in a problem like this, unless there's more complicated expressions involved. If there's more in the numerator and such, you might not want to do it this way. But when there's just a constant in the numerator, I can just rewrite it like that. And now I can use the chain rule. The t squared plus 1 is on the inside. The negative 2 power is on the outside. So I start on the outside, taking the derivative of blank to the minus 2. You'd take the minus 2 out in front, and then reduce that exponent by 1. Well, minus 2 minus 1 gives me minus 3. If there were just a t in the inside, then you'd be done. You put your t here and you get rid of your negative exponents. But I've got a t squared plus 1, so I put my inside function back in to my derivative that I just took, and then I multiply by the derivative of that inside function. And so what I get is minus 2t squared plus 1 to the minus 3, and then this derivative is just 2t squared. So putting this all together, getting rid of the negative exponent and combining the 2's, it looks like I'm going to have a minus 4t over t squared plus 1 to the third power. So that would be my derivative for that function.